Welcome back to the Scaling Tech Podcast, the podcast for leaders of software engineering teams. I'm your host, Arin. In today's episode, I'm speaking with Sid Rao, a former leader at Amazon Web Services and now the CEO and co-founder of an AI startup. We're going to talk about the pros and cons of generative AI and what engineering leaders need to know as they architect their applications and business models around Gen AI. Join me today for this conversation with Sid, and let's get past the AI hype and learn how to apply it in your applications.
Welcome to the Scaling Tech Podcast, where we help you manage your growing engineering team. Through expert interviews, we help you navigate the challenges of leading, hiring, growing, and nurturing your tech team to deliver the value your customers demand. Brought to you by agilityfeet.com, experts in staffing engineering teams in Latin America for clients globally.
Sid Rao is co-founder and CEO of Positron Networks, which is a funded startup focused on high-performance computing. Positron provides an artificial intelligence and machine learning service for scientific computing in collaboration with researchers to drive productivity. Sid is a highly accomplished software development leader who was previously the general manager at AWS for the Amazon Chime SDK, and he's led many teams to implement latency-sensitive and operationally excellent distributed systems. I'm very pleased to have a discussion today with Sid about the pros and cons of generative AI. Welcome to the Scaling Tech Podcast, Sid.
Thank you. Thank you for having me. I appreciate it today, and it's great. It's going to be great to get into some of the topics you wanted to cover with me today.
Yeah, absolutely. I'm really delighted to speak with you again, delighted to have this opportunity on the podcast to talk about a really interesting topic that is on the top of everyone's minds, and I know yours as well. And I said, since a lot of your work is with scientific teams, I want to start with what I think is one of the most important questions around the use of Gen AI and scientific research. And that is Gen AI capable of having new thoughts? Or said another way, can generative AI help scientists to actually make new discoveries or just restate an existing belief?
That's a great question. When it comes to generative AI, there's a lot of talk about rationalizing new ideas, coming up with new ideas, being able to actually think on your own or think for your own. And generative AI as a tool, as we've all experienced probably over the last several months, whether using ChatGPT or an Anthropic model, it's still having some challenges around coming up with unique or new concepts. And if you look at the underlying algorithmic structure of what a generative AI algorithm is, that should not be surprising to anybody. I mean, ultimately, it is a probability machine for emitting, concepts based on historical data that it's read, or artifacts it's found across the internet. But in scientific research, that is still quite useful when it comes to trying to find concepts within existing papers, distill an existing paper or piece of scientific research or a patent. These are, it would take, if you think about it, it takes a researcher, 2 to 3 hours to read a paper and come to the essence of what that author is thinking about and truly understand a paper. I mean, they can skim it, but it'll take a couple hours for them to get to distill that paper down to its most essential thought. With generative AI, they can cut that down to minutes. So finding, content and aggregating content and connecting content. I'm super excited about the connected object graphs we're starting to see used in large language models and generative AI, because what that'll allow a researcher to do is find related content and combine topics together. But in terms of coming up with unique, fundamental, groundbreaking innovation, I'm sorry, that still requires a human to get that done.
No apologies necessary there. That's good news.
That's right. We're still required to do that. But, it's a lot like coding. I often will meet venture capitalists who now feel that software development is a skill that can be 100% automated, and the code will just show up from ChatGPT, and it really requires it's a really shallow understanding. I call it MBA grad understanding of software development to say, ChatGPT could just emit the entire service. You still have to innovate. You still have to understand operational excellence. And all it means is that a software developer, just like a scientist, is moving away from being an expert tactician, where they're emitting code in the case of a software developer, or in the case of a scientist, they're having to do perhaps very cumbersome mathematics or calculation work, and they can delegate that to the computer. But as to the ultimate understanding of the thought process or the business policy or the technical thought process that's required for that innovation, they still have to do that on their own. They still have to have a fundamental understanding of the underlying topic. So I hope that answers your question as to what you were looking for in terms of the role generative AI has in scientific research.
Yeah, no, it's very helpful, and especially since my background, as you know, more in software development than it is in scientific research. I appreciate the analogy very much of how AI is not going to replace developers, and you still need a creative human element to kind of direct it in terms of what you need, and then also you're probably getting pieces of information from the AI rather than a completely developed product. And so you have to not only have the creativity to know what you want, you have to have the knowledge to know how to ask for it. You also still have to have even just the basic coding skills to pull it all together into a cohesive software application that's actually useful to people, right? I think that's a excellent analogy for sure. It makes sense to me, and that makes sense too on the scientific side. And so, in a way, like my question of can Gen AI come up with a new scientific discovery is a bit of a shallow question in itself, a bit dismissive because that's not. While maybe that would be great, that there's still a lot of role there for human creativity and should be, but that doesn't mean that it doesn't provide value. And so I like the way you described the value of that and going through scientific papers and distilling learnings from that, helping the researcher to know where to look more next, that sort of thing. So that makes a tremendous amount of sense to me also because I think it is analogous to ways that Gen AI can be used in lots of business purposes as well as scientific. And I'm sure we'll get into more of that. But I'd like to first hear a little bit about your work with Positron. I know you've been operating in a stealth mode. What can you tell us about your work there and what you're up to?
Sure. When I was at AWS, you remember me probably from my time in real time comms and real time communications. And real time communications has gone through quite a transformation, especially after COVID-19, where it became less around scaling audio networks or video distribution or audio distribution. And it really became the application of artificial intelligence and machine learning to that underlying audio or video or content transport that these services are doing. And so while I was at AWS, I was very fortunate to be exposed to some of the best, talent in applied science and artificial intelligence, the application of machine learning concepts. And I'll tell you something. I had some of the best audio scientists in the world, and some of the best video scientists in the world. Multiple PhDs, and from Caltech, from MIT, and they were spending $1 million on their AWS bill on a per scientist basis. And when I dug into that, and $1 million a year, and when I dug into that expense, I learned very quickly that while they're really, really, really talented when it comes to the algorithms behind signal processing, noise suppression, background blur, all these various different, machine learning mechanisms that you would apply to real-time communications, they had very little cloud experience and cloud skills. And so what Positron's doing is saying, look, fundamentally, we believe that high performance computing, scientific computing, is going to be essential to scientific research. The mechanisms that scientists use to gain access to this high performance computing today is legacy and mired in a bunch of old techniques, including everything from a Slurm cluster to these some institutions have advanced Kubernetes mechanisms, and there's an opportunity to help a scientist where they are today, where they don't have a lot of experience with cloud services, cloud technology, and provide them a cloud computing mechanism to get their job done. Modernize their access to scientific computing, the way that institutions collaborate on scientific computing, the way they can monetize that infrastructure as well, and the business models that come with that. So that's where Positron is focusing right now. I mean, ultimately, when I spent time with about 40 to 50 institutions across the United States, there were a couple trends I learned about. One was that scientists had very limited cloud experience. They were also fearful of the cloud. They were scared of AWS. In fact, having the AWS logo on my shirt probably was a problem versus a positive for the first time in about a decade. And as I dug into that, it came down to they're scared of the AWS bill. It's bit them so many times where they allow their postdocs or their research assistants to gain access to all this wonderful GPU and CPU enabled computing infrastructure, and the bill shows up and it's $500,000. But it's not just a financial or economic problem; it's a usability challenge as well. Like, to a scientist, they on average about 40% of them have less than 2 years of Python experience. On average, what we found was S3 was a very complicated API. When I called it a simple API, I got some eye rolls. Ultimately, I think it was definitely a culture shock for me as I started to engage some of the most talented minds when it came to even high performance computing and parallel and distributed computing and computer science departments, to find that no, actually they really don't have a lot of cloud experience. They need help. There's a large amount of money that they're still spending on these problems. And it's a legacy market that needs some help and some level of disruption. And that's what we got focused on. I think it was a little bit accidental how I got pulled into it. It came from that background of managing applied scientists, machine learning engineers, and scientific computing means something a lot bigger than just simply building artificial intelligence and machine learning models. However, because of generative AI, because of ChatGPT and Anthropic and all these various different services, every scientist out there, whether they're working on environmental science for NOAA or they're working on, computational biology, they all feel now that they have to embrace model creation, model engineering, model development as just a fundamental tool in their tool belt, just like a Benson burner, basically, if you're in chemistry. Now they think of LLMs as just another tool that they have to use in their tool belt to be successful as scientists in today's day and age. And I think the best thing I heard, the funniest thing I heard from a director who I was talking to at the National Science Foundation was, LLMs are now, if you don't put the term LLM or generative AI somewhere in your grant application and talk about how you're going to leverage artificial intelligence to make, as part of your grant application, you will not be successful in receiving grant funding these days. So I think, it's put a lot more pressure on these institutions in terms of how do they manage, acquire, procure, and distribute scientific computing resources in this new world of generative AI model creation, and with the scientific core that is still relatively naive when it comes to cloud services and the capabilities that cloud services can have. So hopefully I answered your question without telling you exactly what we're doing, because you'll have to wait for a launch to learn about that. But I think you got the general idea as to what we're up to and what we're focusing on.
I want to take a moment to tell you about our sponsor, WebRTC Ventures. At WebRTC Ventures, our teams are experts in building live video into your web or mobile applications. We've literally built hundreds of them. We have over a decade of experience using both open source and commercial media servers in a wide range of industries, including telehealth, edtech, broadcasting, and more. We also publish a lot of helpful tips and industry interviews on our website and our YouTube channel. So be sure to check out webrtc.ventures and we can help you build, scale, and deploy your video solution. So, what do you see? What industries do you see as affected or improved by Gen AI? And how did you come to focus on scientific computing among those industries?
Sure. Look, generative AI, I think, has impact across anything where there is an automated processing of information involved, whether it is creating, doing legal work or, and looking at contracts for contract automation, insurance processing. We see generative AI now getting into almost every single aspect where there's an automated process that requires you to interpret an ambiguous amount of text or image data or video data or some sort of raw communication data, and do it with some level of intelligence, but not necessarily enough that requires rationalization, rational thought, design, or innovative thinking at this point. So science has no different. Like if you're when it comes to assembling data, going through data sets, converting data sets into standardized formats. We see applications of generative AI all the way down to even the concepts like I'm doing weather data and I want to collect moisture data across 75 different institutions across the United States, and then I want to aggregate that data and present it to some service to do a better job forecasting the weather in southern Indiana. Like, I mean, these are the kinds of applications we see for generative AI. So I don't think that generative AI as a concept is very different in the scientific world than it is in any other practice, whether it's legal, insurance, healthcare. But I think there are some subtle differences, which is the more and more the scientific research requires some level of precision or accuracy to be successful, the more I see fear and anxiety across the customer's face when it comes to application of generative AI. Hallucinations are still a real big problem in the industry. The error rates of like 1 to 2%, like the way it was explained to me was, if you're doing, I mean, I'll give a very stark example. There's a group I'm supporting right now who's doing cancer research, and they're doing oncology related screenings of both chart data as well as radiological data to determine if somebody has got colon cancer. And the way it was explained to me is a hallucination there is going to be a tragic outcome for somebody. Either A, it's a false positive or a false negative, and it's an extremely dangerous thing. And yes, you can do fine tuning. Yes, you can do a bunch of other work, but ultimately accuracy is still an issue. So when it comes to scientific research, absolutely, it comes down to accuracy matters, and but then you get some of these fields where it's an assistant, where it's a enabler, and it's really just a productivity enhancing tool. And in those environments, I feel that generative AI is going to be most successful, is where somebody's productivity can be improved by an order of magnitude or 2x just by getting rid of rote repetitive tasks. Like, so in our world, for example, we're looking at how can generative AI be used for optimizing where to send code for execution. Like, what is the optimal place to send it from an infrastructure perspective, from a delivery perspective, to ensure that there's a optimized execution environment which costs the customer the least amount of money. And there are lots of those types of models coming out now in terms of optimizing where do you run code, how do you run code, the run times, and migrating code from older versions of compiler techniques that are out there to newer versions of compiler techniques. So again, when it's repetitive, manual, kind of productivity killing tasks that still require some level of intelligence, I think generative AI is going to do a great job in that environment where it's highly accurate, requires rational thought processes. I think until you see some of the work that's being done around object graphs and knowledge graphs get a little bit more advanced, generative AI is still out of reach of those industries right now. And I think it's really disappointing to people because they'll often go to an LLM or a generative AI algorithm, they'll try a task out, they'll see that it's successful, and they'll go, well, why can't I keep doing this at scale? Because it worked once. And what they don't realize is this is a probability machine. It is like playing roulette. And once out of 100 times, it will give you a failure right now. And that one failure, if that one failure only costs you $5 of lost productivity, nobody's going to care. If it costs you $50,000 of impact, yeah, that's a big deal. If it costs you $500,000, you could definitely not think about doing it. So I think that's the caution. You have to really look at what is the cost of failure at a 1%, 2% failure rate. Is it if it's too high, you really can't use generative AI until those hallucination rates come down, and ultimately we will never be able to completely get rid of hallucinations. This is a nonlinear probability mechanism. It's mathematically going to be very difficult to completely eliminate hallucinations and error rates. We can reduce the frequency, but we can never get rid of it.
Yeah. Yeah. No, it's a really interesting problem to think about because um, if you compare it to human error, that's a question too, right? Is the hallucination rate worse or better than human error in that particular situation? And so, what's the relative impact? But and in some cases, it may be better or it may be worse, right? But we talk about like smart cars being able to drive better than humans, especially if they were only smart cars on the road, right? So what's the context of the situation that we're looking at, and the relative impact of that error?
It's interesting you mention that because one thing people forget about is, and I've already experienced this talking to researchers and research institutions, some of the best artificial intelligence brains that I think I'm ever going to meet in my life, and it is so easy for them to get mad at an algorithm, and it is so hard for them to get mad at a human being. And this is something that, socially and society wise, we're just going to have to get comfortable with. It's really hard to get mad at, Sid for making an error or your doctor for making an error. It is incredibly easy to kick the chatbot that you see when it comes to looking at an oncological study. So anyway, I mean that's just something that I think we should keep in mind as we go through this adventure. It's easy to get mad at Chat GPT. It's hard to get mad at Sid the doctor, or the computer scientist.
Yeah, no, absolutely. There will be a change in mindset around those sorts of things, I'm sure, and someone more qualified at like the societal level than me to answer that. But even from just a purely technical perspective, it's interesting too. Something that you made me think of is the different levels that we apply AI to, right? So you talked about like at a kind of a behind the scenes and infrastructure level, how do we deploy computing resources? Or if we go back to like audio communications, where you and I both have experience, using AI to improve things that users of say a video application will never know about how the infrastructure is deployed, or trying to use AI to improve audio quality behind the scene without us tweaking any knobs or knowing, right? So you've got that low level infrastructure where AI can be applied behind the scenes. Then you've got maybe a higher level here that's like where you're talking about doing things and thinking of healthcare, let's say, and the scientific community now, where the AI is helping you to go through lots of data and analyze that data, but not necessarily giving you a conclusion or certainly not giving you an individual patient diagnosis, right? So that's sort of a second level where a 1% error rate maybe doesn't have the same level of impact, right? And then there's this, maybe highest tier that we could talk about of where AI is actually being used to help you analyze an individual patient's medical image or medical result and give you a diagnosis around that. And that's where a 1% error rate is going to have the highest impact, right? But if we could apply AI to each of those levels, and if at each of those sorts of different levels of a process, it's improving the efficiency of things by 10 or 100 or some large order of magnitude, and it's doing that at each level of systems that we work with throughout our lives, whether that is in the doctor's office or in scientific research or anywhere else. I mean, the orders of the cumulative orders of efficiency and improvement that this could give us really is where it makes it so hard to imagine what the future looks like 50 years from now, perhaps, right? And I think incredibly interesting to think about.
I think the one cautionary tale, though, that two things I've learned in, look, I like everybody. When I saw generative AI, I thought, oh wow, this is like, my first experience with ChatGPT, and I thought, oh, this is the next thing. But I've had two, first of all, I'm a lot older than maybe the last time I saw a revolution occur in the industry. So maybe I'm a little bit more cautious in my older age. But, what I will say is there were two cautionary tales that I think we all need to think about as software development leaders. And the first is AI is not just large language models and generative AI. And I think it's really great that generative AI has created so much interest in scientific computing, high performance computing, and the need for model creation and model innovation. But I will tell you right now that 99% of the models I see being run through these scientific computing systems have nothing to do with generative AI. They are everything from statistical forecasting models to, like you said, background noise suppression or a background blur on a video, or image segmentation and security type of use cases as well. So model development is not just generative AI, and so I encourage everybody to learn their machine learning fundamentals. It's a little frustrating when I see software development leaders really get interested in things like prompt engineering, or that's like my favorite thing. Like, well, I'm going to learn how to create this JSON from my LLM in the most directed way, and I'm going to spend days of my life learning prompt engineering. Hey dude, like, sorry to be harsh about it, but like, OpenAI is probably going to automate that problem for you and make that problem go away over time. So don't invest your time in like prompt engineering, because as we've already seen in prompt engineering, OpenAI, Anthropic, they're already kind of getting rid of those little cottage industries that cropped up after ChatGPT has started. So learn your ML fundamentals. And I think the second thing that I think we need to be really cautious of when it comes to generative AI is the over promise, under deliver mentality is very common in the generative AI industry right now. And what do I mean by that? Like, look, I've been selling productivity tools since, I don't know, I was probably like 21 years old, and ever since my days at Microsoft, I've been in the productivity business. And what I will tell you, or the entertainment business of computing entertainment business, and what I will tell you is that ultimately people don't buy productivity tools; they buy opportunity cost reduction tools. Is really what it comes down to. And the distinction is pretty important. Look, nobody will give us money just to say the radiologist will do this task 45 minutes faster than the hour it used to take him before. So a task for the radiologist going from an hour to 15 minutes, it's really hard to make that ROI case and that business case to the customer. So the only real easy way is to say, look, you don't need the doctor at all. You don't need the radiologist at all, or you need less of the radiologist. And that is a really, really challenging case to make, because the algorithm at that point can't just speed up a task or automate some portion of a task. It needs to make an independent judgment and reduce the number of people required to make that judgment. Because as a doctor told me out of the University of Utah's medical school when I was engaged with them, here's the best way he put it to me. He goes, Sid, even if the thing helps me do the job 45 minutes faster or allows me to go through 20 scans in the period of 1 hour versus 2 scans, I'm still in the back of my mind not sure that's a good outcome because I'm still going to be very paranoid about did that thing make a mistake? Is am I putting my medical license and at risk? And by the way, I've seen that across many industries, legal, insurance, basically any high judgment industry, which ultimately the value and the improvement value is correlated to the more judgment you need. If you're making high value, high judgment decisions in an automated way, that's an easier ROI than if you're making some tiny, irrelevant decision. So ultimately, I think, we have to be really cautious about generative AI. First of all, it's not just about generative AI, it's about AI. And that distinction needs to be really thought through carefully in most software development circles. And then, second of all, I think it's important to really carefully look at the ROI model that you're applying for generative AI as a software development leader, and don't just apply generative AI because you think, look, I can help a user do a task 5 times faster. Well, that business case is not necessarily a slam dunk like you think it is. If you ever tried to sell a unified communications tool where the ROI is built around, if you may remember this, like, look, this will save you, $20 million a year in travel costs, and you'll be able to do 10 times the number of meetings. Yeah, like those business cases never did well versus look, the executive can do calls from his home was the really the selling point, not the fact that you're saving the executive time or they don't have to jump on a plane. Those business cases didn't do nearly as well as just saying, look, your executives are always reachable and they can always jump in to make a decision. So anyway, I don't know if that's helpful, but that's the way to kind of think about generative AI and the impact from a return on investment perspective, and what does generative AI even mean for the industry.
Yeah, no, absolutely. And I want to talk a little bit about a couple other, other cons that you see as well. I know you've mentioned like open source, the role of open source in generative AI and licensing. Talk a little bit about that.
Oh yeah, that is a really scary topic for software developers. So open source to historically in the industry has meant LGPL, GPL, Apache licensing models, MIT licensing models, right? And we've had a really clean understanding as software developers as to if I see a license and it says MIT on it, we're good to go. And or if it says Apache, good to go. And there's good licenses and there's bad licenses depending on the organization and their perspective. There are licenses that we are allowed to use and licenses we're not allowed to use. Generative AI and licensing open source AI models in a more generic concern is like the Wild West right now. Basically, it seems like almost every AI innovator out there is coming up with their own definition, their own intellectual property licensing rules, and there's two parts to the contract. There's where did I get my information to train my model part of the contract, and what kind of indemnities, limitation of liability will I be able to give my users from a benefit perspective? And then there's the second part of the contract, which is what are you allowed to do with the model? And knowledge distillation is perhaps the most dangerous part of these licenses because let me give you an example. If you use ChatGPT today to train in a teacher student perspective a subordinate model. So let's say that, I don't know, you want to create a sentiment analysis model where input audio, it'll tell you whether the person's happy, sad, or upset. Well, let's say that the teacher for that model is ChatGPT. And so you take the audio, you transcribe it, send it to ChatGPT, ask ChatGPT, hey, is somebody happy or sad based on this transcript? And then you take the corresponding audio and send it to your model and say, output, sentiment of person. Well, if you use the chat GPT model as like a training or loss function for your subordinate model that you're creating here, you have violated the chat GPT terms and conditions. And then if you look at open source models like Llama and some of these other models that are out there, yeah, Meta has some pretty restrictive clauses in terms of how you can use their model. And so I'm really sad about this because you see people out there. Matt Wilson from AWS is a very strong advocate for open source rights and open source licensing, and you'll see him publish, his gripes about, yet another open source model is published with a bunch of restrictive terms, and we're seeing this pretty consistently that open source models cannot be necessarily trusted. And so what does that mean? That means as software developers, one of the beauties of open source was a taxonomy about what dependencies I could take without worrying about having to contact an attorney. Well, now you almost need to have an attorney on call and take a look at each of the models you plan on using. Make sure your attorney gives you gives you an opinion as to whether you have the rights to use that model or not. So I would caution software developers to be really cautious about the open source rights and privileges and transfer of title that come along with these open source models. So yeah, no, I will tell you that they have to fix this because otherwise it's kind of like either the life open source value of these models will be extremely limited, nobody will use them, or everybody will use them, violating everybody else's open source licenses, and you'll end up with kind of like software patents, right? Like nobody really can enforce a software patent these days at scale because it would kind of be like a nuclear winter in the industry if they tried to do it. And similarly, I think when it comes to open source large language models, they're going to have the same problem. So, look, I think the Apache Foundation, one of these types of free software foundations is going to have to, like they did with GPL, publish a standard license and taxonomy for how models can be licensed to each other, or service terms for cloud versions of those models can be issued as well. But anyway, I hope that answers your question in terms of rights and privileges.
Yeah, not only does it answer my question, you inflicted a real nightmare scenario in my mind there of the future of pair programming in generative AI development means that the person you're pairing with is a lawyer, not another developer. Um,
Yes, yeah, I mean, and honestly, I think if we want to really take advantage of generative AI, we're going to have to fix the problem in a jurisdiction agnostic way in the United States as well. Because, like, right now, if you use certain models in the state of Illinois, you're violating state law.
so, Sid, you talked about legal concerns, open source licensing concerns there. Eh, what other concerns should engineering leaders be thinking about as they architect AI-based systems?
I think the one of the biggest challenges that we as engineering leaders need to start really thinking about is what is the actual underlying supply chain cost of the compute required to run these models. I think as engineering leaders, let's go back to the ROI statement we were talking about earlier, where we go, look, we can save 5 hours a day in physician cost or something of that sort. Well, if your ROI and business case isn't very clean and well structured and well thought through, then the problems on how much it costs to run the model become even more, problematic because you really need to have a good understanding of what your costs are to make sure your ROI case actually matches up with that cost basis. And I see this problem everywhere now, where even in the scientific communities that I'm working with, where they think, oh, well, look, I mean, generative AI or some AI model we're creating is got such a rock solid ROI that I can afford to spend money on 100 H100s running in a data center to execute that particular model. So, I think really understanding what is the compute cost, what is the data cost, what's the fine tuning cost, what's the training cost as well. In fact, a lot of folks completely ignore training and just focus on inference, which is a fundamental mistake because, if you're absolutely sure that model will just work right out of the box, which it rarely does, you need to fine tune it. If you're not sure it'll work out of the box, you've got a training cost, you've got a fine tuning cost, and budgeting these costs is still a challenge for most of the leaders. I think the second issue that I would encourage, the software engineering folks to really be careful about is synchronous versus asynchronous programming methodologies and patterns with these open models. A lot of folks think that the latency budget they can apply to generative models is usually in the couple seconds, maybe a couple thousand millisecond budget. No, we've seen latency budgets that go into minutes. And so having an asynchronous pattern for execution of generative models and token emission is problematic as well. The other issue is canary coverage of these models is very problematic. Because they're not sure what the output will be many times, especially from chatbots, it becomes really hard to build canary coverage of whether the model is behaving correctly between version updates, between weight updates that are going on for these models. So building effective canary coverage is also problematic. And you really want to invest time in a canary design so you actually know when your model's not working, especially if it's a critical part of your application or function. So these concepts are problematic, I feel, for a lot of software development teams because they very quickly go from initial development to prototype within a couple of days. And they think, oh, well, look, ChatGPT solves it, or Anthropic, or Bedrock, or one of these service, or Cohere gives us what we need. And what they forget is it is just like any other piece of software. Just because it's really smart does not mean that you don't need to provide software engineering services for it, whether that's the pattern you're using for execution, to how you test it, to how you integrate it into your continuous deployment process and continuous integration process.
Yeah, that makes sense, and that's where the risk of the overpromise that often happens with generative AI really can add up. If as developers, we buy too much into the overpromise and think that the prototype we did is production ready, or our clients, our users, our business that we're producing that software for, believes that it's maybe as easy as advertised when it's usually not, right? And then on top of that, if the compute spend ends up being out of control and what we predicted. So yeah, a tremendous amount of risks here still to deal with, despite the tremendous opportunity also. So these things are definitely worth working with, but at the same time, we do need to go into them with clear heads and open eyes. So, kind of my last question for you then, for the engineering leader who is not a data scientist, who's still learning a lot about this, doesn't have all of the machine learning fundamentals perhaps that you would recommend, what's the best way for them to educate themselves and their teams more on this topic before going all in?
Sure. I mean, I think, one of the things that a lot of people say things like, let's just go use PyTorch and do the PyTorch tutorials, and you'll learn machine learning, or, get yourself like the O'Reilly book or whatever the case might be, and you'll learn how to build a neural network. And that's actually, I think, a mistake, because the number one problem that I find with learning machine learning engineering is the dependency tree is very complicated. Things break. It's Python based many times, and so as a result of that, different versions of Python, different PyTorch dependencies. Next thing you know, you've got a broken development environment, and a broken development environment is very frustrating to most users. And when you go look at most applied scientists, you learn very quickly that they learn machine learning through R, through MATLAB, through Excel many times. You'll learn that their first machine learning tool wasn't Python. And this is, I think, a mistake that happens in our industry is we mix the mathematics with the software engineering. And we think that to learn machine learning, you need to use Python. No, 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 no. I would start with a self contained, highly curated tool that has all the dependency tree and GPU access all for it, such as a MATLAB or such as some of these other tools that are out there. And learn the fundamentals of the mathematics first, the basic concepts of what is a training loop, what does it mean to have a layer, and what does it mean to have feature extraction and output and loss functions, and learn those concepts in a self-contained tool where you're not worrying about dependencies, where you're not worrying about GPUs or where to run it and CUDA versions and things of that nature. And you're able to focus on the math and then start to think about Python. And then only after you're done with that, then layer on the more complex concepts like how do I run this on ARM-based processors with certain C++ dependencies, or on an iPhone, or various different environments. And unfortunately, a lot of ML engineers right now, because I'll just be candid with you, they just want a job, and so they feel like they have to race towards the Python, race towards the TensorFlow or PyTorch, and then you get into an interview with them and you go, "What's a loss function?" And they can't tell you what a loss function is, right? And that's really sad, and it's going to be problematic if people just think, "Oh, if I learn some Python, learn the ChatGPT API, and maybe learn a little bit of the PyTorch tutorial, I'm now an ML engineer." Because how do you know as a software leader who is truly an algorithm developer versus just somebody who's more of a system engineer who has some exposure to these APIs? And I think that distinction is super important. You really want to be hiring like either people who are going to create the model, who are very good at distributed systems. But what you don't want to be hiring are people who don't know how to create the model, and they also don't know how to do distributed systems work, but they have some exposure to PyTorch, ML APIs, and prompt engineering, my favorite term of this podcast, I think. So I think it's important to know what you're getting in this industry, because it's very easy to look at resumes with a whole bunch of different buzzwords, and they are not fundamentally model developers, and they're not truly model scientists, nor are they solid distributed systems programmers you need to do the integration of some of these machine learning concepts into a complicated software application.
Very helpful. I think there's a lot of great stuff in there for people to do more research on if they're not familiar with those terms, and so that they can do their best work as an engineering leader and bringing in the right people to their team. So, Sid, I really appreciate the conversation today. Thank you for all of the insights that you've shared with us. Where can our listeners of the Scaling Tech podcast go to learn more about your work at Positron as that becomes available, or anywhere else that you want to send us?
My LinkedIn profile is a great landing spot. We have a launch coming up and I would say in the next few weeks, and it will be announced via Positron, as well as via LinkedIn, as well as through some of the other social media channels that we use. So be a follower. Follow me on LinkedIn. Join the 7,500 other folks who apparently want to hear what I have to say occasionally. So please follow me on LinkedIn. And then stay tuned. There will be some very clear guidance in terms of how to learn more about Positron, how to try out the service that we're building, because what we're building makes machine learning and development of ML models very easy and accessible to even some of those people who are just getting started in this industry, and gives them that self-contained, curated environment to learn. And so absolutely follow me on LinkedIn, and that's a good place to start. Okay.
Excellent. Thank you, Sid. Well, I am already one of those followers on LinkedIn, so I'll be looking forward to the announcement as well. And we'll be sure to share that link in the show notes. Thanks again for joining me today on the Scaling Tech Podcast, Sid.
Thank you. I appreciate it. And thank you again.
On behalf of the thousands of developers we've placed with our clients, I want to briefly tell you about our sponsor, Agility Feed. Agility Feed has been building nearshore agile teams for U.S. companies since 2010. We were an early pioneer in doing this sort of developer staffing. Our team can help you recruit talented software engineers and technical teams in Latin America. We'll handle all aspects of recruiting, contracting, and payments for you so you can focus on delivering great software. To learn more, check us out at agilityfeed.com. That's agilityfeat.com.